Good morning and welcome to our webinar, Adoption of Wireless for Safety. This is Andre Restano. I'm the Managing Director of the ISA100 Wireless Compliance Institute. So an administrative note, everybody is on mute so that we don't have disruptions during the presentation. There is a control tab at the center top of your screen, and on the right-hand portion of the control tab, there's a question and answer tab. We would like you during the webinar to type in any questions that you have, and we are reserving some time at the end to answer those questions. So again, welcome to the webinar. Before I introduce the presenters, I'll take 3 minutes and go through some fast facts about ISA100 Wireless. Next slide, please. So ISA 100.11a became an international standard, IEC 62734 in 2014. It's a standard that complies with SCEN 320 version 1.8.1. It's also known as Listen Before Talk. It has capabilities in the standard to address coexistence with other radio waves that are in the 2.4 gigahertz broadcast spectrum. So today the wireless portfolio exceeds 44 devices. We have a focus on certification. We continue to build our certified device count. It exceeds 25 today. In April of 2015, GasSecure achieved the world first with a SIL2 certification for the wireless detector, wireless gas detector. So again, we focus on certification to ensure interoperability and best-in-class solutions. Stacked communication modules today are available from 4 suppliers: Nivus, the original supplier; Murata, a multi-billion-dollar technology company based in Japan; and from 2 of our major supplier members, Yokogawa and Honeywell. Next slide, please. So just quickly, the ISA 100 devices that were added in 2015, the count, we added 15 devices, and you can see we have a focus on certification. 10 out of the 15 are certified, and the rest are in line to be certified shortly here. Next slide. So I'd encourage you to go to the website, the ISA100 Wireless website. There's a nice white paper available for download that our technical director authored. There's information about events, the Acima Field Communication Lounge that was in Frankfurt. We stood up 3 live networks with 36 devices from 17 vendors. And a tribute to our interoperability focus, these devices were all set up in the stand on Saturday, and we're ready to go by Sunday evening. So it's just a tribute to the fact that the interoperability and our certification program works well. You'll see some recent information on Jemima, which is the automation supplier show in Tokyo. That was just this past week. And you can find a full list of registered devices, great information on use cases and customer stories, and we think it's a pretty good website with good information. We're getting more than 20,000 web views a month, and it's growing. Next slide, please. So our presenters today are a great lineup. Jay Werb, who's our technical director. He was also the data link layer author of the ISA 100.11a standard. Dr. Penny Chen from Yokogawa. She's responsible for technology strategy and standardization focused on wireless and network technologies. She's also the board chairman of the ISA 100 Wireless Compliance Institute. Didrik Mold, a business manager, Industrial Wireless Solutions, Honeywell, He's responsible for development and ownership of the One Wireless business for Honeywell Process Solutions in EMEA and also Asia Pacific. Diedrich is also the Vice Chairman of the Board for the ISA100 Wireless Compliance Institute. And then Knut Sandeven, he's the CEO of GasSecure, recently acquired by Draeger, so they're a division of Draeger now. And GasSecure develops and delivers wireless gas detectors. Next slide, please. Okay, so I'm going to turn it over to Jay Werb, Technical Director, and welcome to the webinar.
Okay, thank you, Andre. Okay, this webinar is built from presentations last month at the Process Control and Safety Symposium. Originally, this was about 2 hours of material, and today's presentations are quite compressed. So if you want to see WCI's original presentation, the PowerPoint is available on the WCI's website. And again, since there's quite a bit of material today, we're going to go a little bit quickly. But everything is posted to WCI's website, so if you want to review this later at your own pace, you can do that. This webinar will have 3 major sections. First, I will cover some general design principles. Then we have 6 case studies from GasSecure, Yokogawa, and Honeywell. And then at the end, we will have time for questions. Now, the webinar is scheduled to complete in an hour, but we will stay longer if there are a lot of questions. Okay. So first, for context, this slide shows why users are adopting wireless instruments in general. Cost savings is at the top of most lists. When wireless is used, it can do the job in about half the cost and with a much faster installation. These economics enable new and scaled applications. Essentially, this whole webinar is about safety applications that have become financially feasible for the first time due to the lower cost of wireless. Next, we have improved reliability. People usually think of wireless as unreliable, like a cell phone on a train. But for many projects, wireless is justified by improved reliability, like the wireless handset that I'm using right now. Wiring isn't always so reliable, and wireless can add redundancy when it runs alongside a wired solution. When we created ISA100 Wireless, our vision was to enable universal monitoring of equipment and processes, and we also made sure to support performance for control with time constants of around 1 second. Today, as an extra bonus, we are finding that the same wireless can also be used for safety. Okay, so now we'll review some design principles that apply to wireless safety specifically. A lot of the material that follows is derived from the work of the ISA84 Workgroup 8. This team has been looking at wireless safety for about 2 years, I think, and they have a technical report that isn't quite finalized, but it's in pretty good shape. So I used the latest draft as a reference when I created these slides. However, I didn't exactly follow the draft, and I'm happy to thank ISA84 for their indirect help with this presentation, but this is definitely not an ISA84 Workgroup 8 presentation. It just uses a lot of the ideas that they have organized for us. Okay, to get a sense of where wireless safety is today, consider the focus that the ISA84 Workgroup 8 chose. The technical report is guidance for the application of wireless sensor technology to non-CIS independent protection layers. The guidance that's provided is not intended for the use of wireless as a safety instrumented function. Okay, that's nice standard speak, but what does it mean exactly? Let's look at this graphically. This is a graphic that we've used in other WCI webinars. The main point today is that safety appears in 2 places. There are safety alarms in the middle right and safety automation and automated safety functions on top. I circled safety alarms, which is essentially the scope of ISA84 Workgroup 8. And I also put a soft X with the safety instrumented functions to emphasize that the ISA84 group doesn't seem to be claiming to cover such use. That being said, a lot of what follows is pretty good advice generally, not just for safety-related alarms. One of our case studies is actually in the area shown here with a soft X. Okay, here's some more standards talk with key text highlighted. The focus is on an alarm with operator action generated from a wireless transmitter where risk reduction claimed is less than 10. The report provides information on how to establish a design that satisfies dependability and auditability criteria for a wireless safety alarm. Okay, moving right along, let's look at some of the guidelines. Latency and availability are important metrics for safety. The ISA84 Workgroup 8 gives this definition of latency. Wireless sensor network data latency is the time between the acquisition of a measurement value and the delivery of that data via the wireless network to the gateway. Next, consider availability. Availability can be expressed as the percentage of values received within a required response time. So 99% availability means that data is received on time 99% of the time. It can be measured per device or for an overall system. This is the diagram that WCI uses to talk about latency in wireless sensor networks. On the right, labeled A, we have the backbone, which is like a highway. Latency on the highway is usually much less than 1 second. Next, we have devices that are 1 or 2 hops away from the backbone. These are like on-ramps to the highway and should give you latency down to about 1 second. Then you get into the mesh network labeled C. The mesh is like city streets with traffic lights. Each hop is like a traffic light. So your message may need to wait until a neighbor wakes up from a deep sleep, which could take a few seconds or more. Finally, on the left, you have messages between field devices, which can be like a quick drive between neighbors' houses. So generally, wireless safety alarms need on-ramp kind of performance, 1 or 2 hops from a backbone, and carefully configured for specific performance. Okay. The next 3 slides describe some basic techniques used to communicate safety alarms. This diagram shows a publication approach to safety alarms. The field device is configured to send a heartbeat periodically, for example, every 20 seconds. The heartbeat demonstrates that the network is operating correctly and that a device is not in an alarm state. When there is an alarm, the publication rate increases. This picture shows a request-response approach to safety alarms. A gateway is configured to send a request to a field device regularly, for example, every 15 seconds. The field device responds with the current alarm state. And this shows a hybrid of publication and request response, and it's consistent with the alerting approach in ISA100 Wireless. When there is no alarm, a heartbeat is published regularly. The heartbeat contains sensor data such as gas concentration. But when the device enters an alarm condition, a special alarm message is transmitted immediately, and the gateway responds with an acknowledgement. Later, when the alarm is cleared, another message is sent that is also acknowledged. So the idea here is that heartbeats are published on a regular schedule, but alerts can use request response triggered by events. And there again, there's lots of different ways to configure this, but these are just a few examples. Okay. Now we move on to design practices. This slide lists some common best practices for safety-related alarms. These are also pretty good practice for just about any industrial wireless sensor network, especially when safety is involved. The main point is at the top. it is critical to closely adhere to manufacturers' best practices when designing and laying out a wireless sensor network. Those best practices will usually include factors shown on this slide. Configure the network with conservative wireless communication range. Carefully consider reporting rates for each device and also for the network. Consider device battery capacity, radio channel capacity, router capacity, and infrastructure capacity. Locate infrastructure centrally and control hop depth. You can think of the wireless backbone connection as an on-ramp. Make sure that there aren't a lot of stop lights between the device and the on-ramp. Include plenty of path redundancy in the network design. Avoid bottlenecks. This should be covered by manufacturer best practices. Use network layout and simulation tools that are recommended by the manufacturer. And be sure to document the network so that it can be maintained. These points taken together support the overall goal in a wireless sensor network design. Design the network with plenty of margin, and then monitor that margin carefully. Now we move on to security. This table is very similar to a security matrix in the ISA84 Workgroup 8 draft. The main points are summarized in the text under the table. Authentication, verification, and encryption requirements are usually covered by communication standards such as ISA100 Wireless. Access control and key management generally involve adherence to the manufacturer's best practices. Denial of service is kind of a special topic, which is covered on the next slide. Okay. Denial of service is what happens when another radio interferes with the operation of your radio. Intentional interference is from a jammer that is actively trying to shut down your system. That is a denial of service attack. Unintentional interference is much more common. Unintentional interference is caused by use of the radio channels by others. Common strategies for interference include spread spectrum modulation, redundant routing, and channel blacklisting. More generally, radio systems and standards that are proven in use will have field-proven ways to address interference. Recently, there's been a lot of discussion about listen before talk, or LBT. We certainly don't have time to cover that today. But generally, LBT compliance can involve complicated trade-offs, and this is an area where users should just follow the manufacturer's best practices. Denial of service attacks cannot always be prevented, but they can pretty much always be detected with good diagnostics. When safety is involved, follow best practices with systems that are proven in use. Okay, and here are some other considerations that are also brought up in ISA84, and they're all good to mention here. Gateway host communication should use well-known standards with security locked down. Many users have rigorous policies regarding safety alarms in general to avoid alarm floods. This isn't specifically a wireless issue, but wireless makes it possible to install many, many more alarms in a plant. A system that is well proven in use can help address concerns about alarm floods. Battery mismanagement can create a maintenance burden and reliability issues. Again, follow manufacturer best practices. To keep things simple, battery life should be deterministic and longer than an instrument's natural service interval. Data quality diagnostics are also important for wired and wireless systems. Any safety alarm needs early detection and prevention of stale data conditions. Network diagnostics are more specifically wireless. Best practices generally include lots of margin in the wireless design. When the system is well designed, it can keep operating with reduced margin. The operator won't notice a problem because data continues to arrive on time. But the systems people get diagnostics that show a systematic issue that needs to be addressed before it becomes noticeable to the user. Okay, and that completes the first part of this presentation. That was a lot of material in about 15 minutes, and if you want to look at it again, we're going to post all this after the webinar. Now we move on to the real world of case studies. We have 6 examples from 3 suppliers, GasSecure, Yokogawa, and Honeywell. And without further ado, I will pass the baton to my colleague from GasSecure. Thank you.
Okay, thank you, Jay. So GasSecure is now part of Draeger, but we are still focused on high-end wireless gas detection. So next slide, please. So gas detectors, they are used in industrial facilities where hydrocarbon products are handled. On an offshore platform, there may be between 100 and 500 detectors, and on onshore facilities up to several thousands. And the benefits of using wireless compared to wired are that wireless gives you the flexibility to easily place the detector exactly where it is supposed to be, not depending on where a cable can be run. And there are huge cost savings in wiring or no wiring, no cable trays, no junction boxes, and reduced installation time. Normally we save 70 to 90% of the total cost compared to wired, depending on the project. And in some cases, the detectors are difficult to access for battery replacement, and we will then combine wireless with wired detectors. But on most projects, wireless will be a better choice for 9 out of 10 maybe detectors. And GasSecure, we are working with major oil and gas operators like BP, ExxonMobil, Statoil, and they all have clear requirements to detector performance, and especially that wireless detection systems should be at least as reliable as wired systems. So next slide. Many projects also have requirements for detection systems certified according to ISA100 standard. That's the standard governing safety integrity level, which is a measure for reliability. And this also gives requirements to the setup of the wireless system. And this slide shows the difference between a regular alarming wireless system and a seal-compliant wireless safety system. On the left on the slide, is the non-seal system. The detectors will then publish messages at chosen intervals to the gateway or through the gateway, which normally will communicate on Modbus to some controller or even a PC. On the right side is a seal-compliant version. The safety controller needs also to be seal compliant from, for instance, vendors like Siemens, ABB, or Yokogawa. And the controller will control the wireless communication by sending down requests for readings to a specific detector. It will start a timer and an answer, and if an answer is not received from that specific device within a certain time limit, the detector becomes unavailable. And this two-way communication is, or GasSecure bases this two-way communication on ProfiSafe, which is a seal-certified safety protocol. And on the wireless side, it goes on top of ISA100 Wireless. And normally projects with seal requirements will also require a redundant gateway setup, which we can provide. And that means if one gateway fails, you will not lose all the detectors. They will automatically switch over to the second gateway or the redundant part of the gateway. So next slide. Okay, I will show you two application examples. The first one here is a regular alarming system. It was one of the first installations we did. The customer wanted to increase the safety level by installing gas detectors. There was nothing installed from before. And the distances were large, so wired was a very expensive option. And the whole system was set up in about half a day. The customer made a very nice interface to the controller, showing all essential information on one page. You see it on the right there. With gas reading, a drawing of the tanks and where the detectors are placed. It shows battery level, and it shows detector status. The detector status is a collection of diagnostics information, and if this becomes red, the operator can then drill further down to see more detailed diagnostics on the wireless system and the detector. So these tank farms, they are ideal cases for wireless gas detection, and we have delivered many similar systems the last years. So next slide. Okay, this example is a more advanced installation where the gas detectors are connected to the platform safety system and have executive actions. And that means if there is an alarm, normally on two or more detectors simultaneously, for instance, the deluge system or other actions will automatically be initiated by the detection system. In this case, the customer wanted to replace the old catalytic detectors with state-of-the-art infrared detectors. That's a requirement in many places now. So we have installed 73 detectors, but the installation was, in this case, tricky because the platform is designed with completely closed modules where the wireless signals could not penetrate. So we had to engineer with 16 gateways. But still, the customer has estimated that we reduced the installation time with 90 to 95% and total cost with 80% compared to wired. The same customer is now installing 125 detectors on an onshore facility where they're using 2 gateways in an area which is about 500 by 500 meters. And the whole system is fully Tilt 2 compliant. So, okay, so this was a taste of wireless used in critical safety applications, and I'm happy to take your questions after the last presenter. Thank you.
Okay. To adopting wireless technology for safety application, Yokogawa has worked with GasSecure and provide CO2 certified wireless gas detection systems to the market. The system integrated the wireless gas detectors from GasSecure and the Yokogawa ISA100 Wireless Gateway on the multi-vendor interoperability environment. The gateway has implemented Profinet protocol in order to communicate with the controller, which has ProfiSafe for the rapid response with low energy consumption. Today, there are several successful deployments at the refinery, offshore platforms, LNG facilities, or as example from South Asia to Northern Europe. Now next, I would like to introduce 2 additional use cases for safety applications that differ from gas detect use case. Next page, please. The first use case is a tsunami warning system using Yokogawa ISA100 wireless technology. After the Great East Japan earthquake happened in March 2011, license learned that tsunami warning system is needed. Since tsunami is usually preceded by the sudden tidal wave, detecting the sudden lower of the ocean tide level near the shore may indicate tsunami after earthquake. The challenges are long distance from ocean shore to the control center. They are large coverage area. In general, there is no electric power further away from shore. The reliable communication system is needed to support the rapid response time. Wireless technology has been chosen to overcome those issues. The solution is use level meters with wireless adapter installed on storm surge barrier, you can see in the picture, near the plane to monitor the tide level sensor. Level sensor, which is lower, you see the picture. Fully redundant communication passes to support the reliable communication with rapid response. It has over 600-meter communication distance without repeater. The benefits is safety improvement, quick project execution with low project cost. This is obviously the green field. Next slide, please. The second use case is fire prevention in the cook pre-treatment process. The application is monitoring the sign of fire, and activate extinguishers of the cook pre-treatment process in the steel plane to ensure plane safety. The challenges is normally the fire broken out requires 10 seconds of responding time. Well, that means 5-second update time is mandatory for the temperature sensor and no more than 5-second transmission delay to the control center, as you heard what Jay has described. It requires a high reliable wireless monitoring system with long distance and cover large area. This project has another very difficulty is the difficult environment with a lot of obstacles. The solutions, a single wireless system with 50 wireless temperature transmitters were installed along the bell conveyors. Other facilities in the cold yard, the cook furnaces that used to for the cook pre-treatment process. The temperature update rate is set to 5 seconds. The system monitors the sign of the fire and activate extinguishers. If there's any temperature measurement, it exceeds the predetermined threshold. It deployed with Yokogawa Sky Mesh concept design with deterministic mesh topology to create full redundant wireless communication paths such as dual cast from sensor to access point and routers, duplicated routers, redundant management stations to ensure system reliability. The benefits are enhanced plane safety and reduction of the overall project time, significantly reduce project cost. Next, please. So based on Yokogawa experience, the reason for adopting wireless for plane safety include following. Prevention measurement, such as process condition, status monitoring, asset condition monitoring, accident avoidance, limited damage of extension, such as alarm and warning, use gas leak detection, safety shower detection, tsunami detection, emergency shutdowns, using fire detection or activate extinctions. Human safety, such as people tracking, communication, or navigation during evacuation. Next, please. Well, deploy and implement wireless system for safety does need to take a careful consideration from project planning to execution. In general, it including 4 different elements. First is a field device, such as wireless sensors, whether it supports safety layers, can it cover long distance, whether it supports multi-vendor interoperability in order to ensure the best in class. Wireless infrastructures, such as redundant network capability, backbone to support a large network deployment, coexisting management, security, and so on. Network engineering, such as flexible network topologies. In Yokogawa, we use sky mesh concept for network design, whether it supports safety protocols such as ProfiSafe. Network operation and maintenance, such as network monitoring tools, predictable and long battery life, and go on. So our conclusion is wireless technology improves plant safety. It reduces overall project time and significantly reduces project cost. Thanks.
Thank you, Penny. This is Diederik Mol speaking from Honeywell. And, just as a short, brief introduction, Honeywell is now in the industrial wireless business for over a decade. And thanks to the ISA100 standard that we now have, in recent years we are able to easily and seamlessly integrate sensors and other applications from other vendors, which enables us to create even more value for end users than we were able before with our own devices. So that's the beauty of this interoperability. We deliver projects onshore, offshore, at sea, and we have a delivery capability in all major regions for oil and gas refining and other industries like chemicals. Next slide, please. Whilst working in this industry, we are faced with multiple questions, and this was a very interesting one that we came across in the Middle East 2 years back, when a customer came to us and said, well, we have a compliance issue, we need to quickly deploy a perimeter monitoring installation to detect gas. We don't have budget and time to do that wired. Is there a possibility that you could do this wirelessly? They had done some trials before with another technology, wireless technology, but they failed to meet the stringent 3-second cycle time requirement between detecting the gas and having sounders and beacons all in synchronized alarming around the fence, because there was also an office area where people needed to have that alarm at the shortest possible notice. Well, we took on the challenge and set up a test installation, and we were able to demonstrate to the customer that we were able to meet this 3-second cycle time requirement with the solution based on ISA100 wireless. It also needed to be fully redundant. And as a result, we come up with a solution based on our universal transmitter that has both inputs and output capabilities, so you can trigger an action. Of course, gas detectors, solar power panels, backup batteries, and field device access points as part of the solution. So next slide, please. we conducted a factory acceptance test in our customer solution center in Abu Dhabi in March 2014, and we were able to demonstrate time over time to meet this stringent 3-second cycle time requirement. And the customer, of course, wanted to rigorously test our solution. And well, we were happy to see, and we were also confident that to be able to meet all those requirements and beyond, as ISA100 Wireless is a very robust solution nowadays. So that's all under control and very robust. Even if you integrate third-party vendor equipment, it's all up and running in a very short time frame, and finally robust going forward. So as a result of this FAT, we were good to go to install it, and it is now at the customer site since June 2014, and we were able to compare to a wired solution to almost half the cost for the end user compared to doing this fully wired, and at the same time we're able to deliver the project and execute it and commission it in about 1/5 of the time that you typically would need to do this in a wired solution. So wireless is now becoming a more and more attractive solution. Certainly now budgets are under pressure at current oil prices. Next slide, please. Another interesting project that we did was as a result of recommendations for safety compliance in India. It was the so-called Mr. MB Lal committee that had did a study on behalf of the government to further increase safety at terminals. As a result of two tragic incidents in the years before. All these recommendations were, of course, putting cost constraints on the end users. So, although they understood that they had to comply with these regulations, budgets, of course, would be tight. And again, with these wireless solutions, we were both able to meet these compliancy regulations, these compliancy needs. The FlexLine radio gauge that we bring to market is a SIL 2 rated device also. And as a result of what we could demonstrate, we were able to secure this project, which is a nationwide deployment in India, over 49 locations, and the total scope of the project was over 500 of these FlexLine radio gauges. So it was our largest project till date in one go. And we, again, thanks to the wireless capabilities, we were able to deploy it in a very short time frame. Next, please. So, originally, wireless started with just, let's say, sensors for monitoring type of functions, but shortly after, we already saw requirements that go beyond that. And as we see today, we see more and more safety-related applications. Those could be safety-related to process safety, but also to personal safety. And just as an example here, you see some other features that we bring to market and serve customers with, like safety shower monitoring solutions, but also a panic button, as you can see at the top right, panic button that can be pushed can be installed at any place in the plant, and just as it's being pushed, we know that somebody's in trouble, and an emergency response team can go to the spot without any delay. And on the lower part, you see those are Wi-Fi, so those are not the ISA100 Wi-Fi applications that we all have in one network application for personal safety, like personal gas detection with location identification, mobile applications for to be better informed at the scene of action in case of firefighting or emergency response activity. And then, as you can see at the lowest part, there's a customer requirement that we were faced also in the Middle East for a mobile CCTV solution on the emergency command vehicle to provide real-life imaging of the scene of action in the control room. So it doesn't stop wireless and industrial wireless, and certainly ISA100 doesn't stop with just monitoring type of applications, but more and more there's a safety angle to it. Next slide, please. So, and in these two cases, we could clearly see that thanks to the unique features of ISA100 wireless, we are not able to meet these regulations and meet these near real-time requirements of a solution. Especially when safety is at stake. These near real-time alarm requirements that we are able to address with ISA100 are, I think, a unique offering in the market. In early years, we did smaller type of deployments with let's say 10, 20, 50 type of scale sensors. Today we are already doing 800 and beyond. Next year we will go over 1,000 in one deployment, and today the largest that we have in place is already 800 fully redundant ISA100 devices in one network. So I think with that we could say ISA100 is a mature and versatile offering, and thanks to all the vendors that bring these applications, we are able to even better meet customer needs in the market. Thank you. Over to Jay for a summary and then Q&A.
Okay, hello, this is Jay Werb again from WCI. Before the question and answer period, let me highlight a few of the themes that we covered today. First, cost savings from ISA100 Wireless enable scaled adoption for safety applications. Second, ISA100 Wireless is commonly used today for safety alarms. We saw several examples of that today, and there are many more examples that we could have presented if we had more time. Third, we're starting to see SIL2 ratings that should accelerate integration with safety systems. I hope it's obvious that all of the examples today meet very stringent performance requirements, but with the SIL2 ratings aren't always there yet. And it appears that as we start getting the SIL2 ratings, that will open up even more applications. And my final point, of course, is that ISA100 wireless applications are well proven in use. And if you follow the manufacturer's best practices, you can meet the rigorous performance requirements for safety. And with that, I'll pass the baton back to Andre and Mike for questions. Thank you. Now, I put the just for reference, we put a summary of the use cases today so that you have that for reference. Thank you.
Thank you, Jay, and to the rest of the presenters, it's great information. Thanks to Penny, Diedrich, and Knut. First of all, this webinar is recorded, and the slides will also be available on the ISA100 WCI website. It'll probably take till later this evening or by the end of business tomorrow, Thursday, East Coast time, USA. Okay, so number of questions. So one, I'll answer this one. So there's a question about how are devices certified. So we certify ISA100 wireless functional conformance here at ISA headquarters. We have a certification lab and pretty well designed certification technology and appliances. So the ISA100 wireless certification is done here. For the SIL 2 certifications, those are done by well-known labs that suppliers typically work with every day, labs like TUV, Exida, and others. The GasSecure device was certified by Exida. So another question. This is kind of a broad question. Do you think that wireless will someday replace wired for safety systems? And I'll just leave that to the panel.
Well, maybe I take a little bit. From personal point of view, I don't think so. Wireless provide more opportunities to enhance safety for the safety systems. Instead of replace wired safety systems, we do see more complementary and add additional safety reliability or functions, not a replacement.
Yeah, maybe one addition to that. Thank you, Penny, for sharing this. So this is Diederik Mol speaking, Honeywell. I think that safety systems indeed, certainly to the nature of the business, will be wired. But I think wireless can be a great addition to better plant and personal safety going forward. Let me give you one example. Quite a few years back, there was a hurricane coming on shore and damaging infrastructure at one of our customers' plants, and as a result, a lot of cable trays were just non-functional anymore and cut. We also had a wireless network at that site, and that wireless network, although also one of the access points was damaged, but because of the redundancy, the network still kept performing during the hurricane and after. So it was well able to just continue to provide the information that it was providing also before. So wireless can be an excellent addition to just a wired system for adding safety related functions, also information. If you're completely relying on wired, and if your cable trays are damaged, you will be in the blind of what's happening at the other side of the incident at your plant. And with a wired, fully redundant wireless solutions, you will be able to still get that information or communicate with it. And so, another parallel example from just every day. I think if there is somewhere a disaster like an earthquake, typically wired infrastructure is disrupted largely, and it takes months before that's up and running again. Usually cell phones or wireless technology is still available after the earthquake, and is available and otherwise is available after just a short interruption, like a half an hour or so. So I think the combination of the two, wired and wireless, is the perfect path forward. But again, wired will still be part of safety systems going forward, for sure.
So there's a question, it looks more like an architectural question, and it could be different for each supplier. But the question is, where does the alarm and the alarm setting live? Is it in the device or in the DCS where the operator gets the notifications?
All right, for GasSecure, that would be in the DCS. So the gas detector would provide the reading, and the DCS or whatever controller you're using would determine if it's an alarm and what kind of alarm, and an action should be triggered.
Okay, there was a question about denial of service strategy and how, can you explain how blacklisting might be used as part of that, if that makes sense?
I guess that's for me, Jay. I think yes, that's generally built into the that's built into the protocols generally. The denial of service things I listed, I was more or less transcribing from the ISA84 Workgroup 8 stuff. I think they did mention blacklisting, and I just listed that as something that was covered by the underlying protocols typically. But yes.
So there's another question. Are there plans to apply ISA100 standards to general process automation practices for Wi-Fi use?
This is Diederik speaking. I'm not aware of those plans, but indeed the ETSI, for example, the European Commission is constantly reviewing fair use of the unlicensed band, and I think that the ISA100 wireless standard has a couple of very good thought-through technologies specified that potentially could inspire other committees also to adopt those, but I'm not aware of specific plans.
So another question, in industrial communication, we have the trend of signal pollution and of pushing office TCP/IP communication into industrial areas like production automation. How can ISA100 help?
I'm not sure I understand the question. Can you read that again?
Yeah, it says, the way I read it is, it's asking about there are a lot of other radio pollution from other general office communications over TCP/IP networks. I have to believe that we're talking about wireless. This is how can ISA100 help in a crowded signal environment.
I'll take a crack at what I think they're asking. There's two aspects to it. The first is that ISA100 wireless generally doesn't add a lot of traffic to the network because the devices are awake for a very short period of time and they complete their business quickly. So it certainly doesn't add to the congestion in a significant way. And the protocol is designed to work in a congested environment, and that's what proven. That's what a lot of the proven in use gets back to is how well do these systems work in practice in a congested environment, and we're starting to get pretty good experience that it works pretty well. I'm not aware of any reports that we significantly have interfered with anybody else. Andrew, do you think that answers the question?
Yeah, I mean, it basically was asking about coexistence capabilities, I think.
I think that's what they were asking, yeah.
Yeah. So there's, this is a, just clarifying some of the terminology. So in one of the early slides, there was indication that the time was indicated as critical and the safety reduction is below 10. I don't recall if that's 10 seconds or what the measure was. Then in a further slide in the SIL2 with a safety reduction shows a number of 100. So I think in one instance, I'm guessing you can expand on this. In one instance, we're talking about 10 seconds, and the other section is section is the technical term, 100 milliseconds.
I'll try to handle this, and an actual safety expert might tell me I got it wrong. But the ISA84 Workgroup 8 group decided to focus on applications where you're claiming less than. Let me get. I should jump back to the slide if I can. This is a very technical point. Sorry, it takes a while to get back through all these slides. It's a very good question. It took me a long time to figure out what they were talking about. Okay, they're talking about this. So this is the focus of the IS-84 Workgroup 8. And the idea is that when people are installing wireless for systems where they're claiming a risk reduction of less than 10. So basically, this is SIL 0. So people are installing systems. The systems work great, but basically for approvals reasons, they're just saying, okay, even though we can't prove a risk reduction of greater than 10, it's still worth doing. Okay, and then the IS-84 Workgroup 8 group is putting together a set of guidelines for that. Now, they're not claiming that these guidelines are suitable for when you're doing SIL 2, for example. Now, a lot of the same principles would apply if you're using SIL 2, but the ISA84 Workgroup 8 isn't scoped to do that. They're just trying to put together guidelines when you're claiming a risk reduction less than 10. Now, if anybody else on the line has anything to add to that might be helpful.
So there's another question here, and I think this is one that you actually looked at in one of your studies, Jay. What are hidden labor costs to replace batteries? Is there a time frame when those costs surpass wired devices?
Well, that was that's covered by. Let me go to the slide where we covered that. And I have weasel words for this. Okay. So you'll see it says battery management, and it says battery life should exceed the instrument's natural service interval. So the idea is that if your system is designed, the system follows that idea. Most devices need to be touched at some interval, 1 year, 2 years, 3 years, whatever it is. And the battery life should be deterministic. It should not be a random battery life. And that the battery life should be long enough to exceed the natural service interval. So that's now when your battery life is shorter than your natural service interval, then yeah, you're going to have to touch the device extra times. Now I don't know if the device suppliers have anything to say about that. They might have a different idea.
Well, Knut from GasSecure may add to that. There's also different philosophy between different vendors. Some vendors provide battery packs, Others, like GasSecure, allows the user to change the battery itself. So reusing the battery packs and do the cell replacement themselves. And it's also important that the battery packs are designed for exchange in hazardous areas, so you don't have to take down the instruments to change the battery.
So the next question, go ahead. I'm sorry, Penny, go ahead.
Oh, maybe I just add one more aspect on the battery life. A battery life really is a combination of many aspects in the network, including sensor, including network design, topology, and the communication paths. So it is not a single element, so that when you do network design, we talked about network design engineering, you do need to consider, do not overburden some of the sensors that you use for critical and safety applications. So well-designed network and the flexible network topology allow you to do that. It's very important. That's why ISA100 committee, when it started, it has well considering this topology, allowing flexible different type of star mesh and available or hybrid, both available for applications.
So the common question that we get, I'm guessing on every webinar that we've ever done is, what is the battery life experience? How long do
allow me to say a few words to that. So Diederik Mol speaking. Battery life, indeed, it all comes to a good design and implementation of the network. If for whatever reason that's compromised, you will get retries, or if you allow sensor routing, that of course per definition will use additional battery power and therefore compromise life. If performance is important and maximum battery life matters, then we can design this network in such a way that we easily can arrive at battery lives that are close to the shelf life of the battery. So it's all a matter of how to design and implement your network, and that I think is something that again is unique to ISA100 Wireless, because there the end user can decide whether sensor routing is allowed, yes or no. With other standards, that's not an option. Sensor routing is the default. So there you cannot optimize your battery life by changing the network design. With ISA100, that's possible, and you can just have the transmitters, the battery power transmitters, only communicate with access points, and for that reason have maximum battery life. And again, the battery life can last as long as the shelf battery of the shelf life of the batteries. So I hope that helps get a better understanding. There's white papers around that. Honeywell did publish a white paper called Alive on batteries. That might be something that you might want to consult and read through. But if you have any questions, please feel free to specifically on your need, feel free to connect to any of the members of ISA100, and we will no doubt be happy to explain you in more detail and look into your specific case.
Thanks, Diederik. We've got lots of questions, and I'm thinking that we won't get to all of them. But we're going to retain these and see if we can answer them somehow in the future, either with follow-up email as a follow-up to this webinar. There was an interesting question. In some countries, is an RF survey required before deployment of any wireless? Can you all talk about any experience in countries where an RF survey may have been required?
I'm not aware that it is being required. Again, Diederik Mol speaking. So I'm not aware of countries that require that. It's something that we will do a consultative discussion with any end user about any end user need, and then go through the do's and the don'ts. If it's serving a critical need, it could be very useful to spend a little bit of time and efforts up front, like doing a front-end engineering design, which you also would do at a wired system, and that could part of that front-end engineering design could be indeed a RF survey or a site survey, an RF site survey as we call it. But it's not always possible. For example, if you do a greenfield project, there's no need to it's not even possible to do a site survey, RF site survey up front. We have design tools that allow us to make a design from as a desktop activity, and then when finally the construction is being erected, we will be able to do some fine tweaking based on RF findings at that point. And again, if there is if a network is designed properly for its need, with enough redundant capabilities, then it will work without any interruption. If you have a very small budget and you really need to lean out the network, and that's just a small network with no or just a few redundant paths, then indeed you will have not the redundant. You have not the assurance of the performance that you would see in a typical larger network with those redundant paths. So it all depends on those kind of situations where if time permits to do an upfront study or not, and if that's valuable. We definitely have done a lot of studies that prove their value for the final design to customers, especially in brownfield. It's something that is done a lot and proves its value time over time.
Yeah, agree with DJ. I think this is, I haven't heard any country require for RF survey, but in best practice, it is always good for you to do site survey. Especially you have critical type of safety application, relatively critical safety type of applications, or you have large wireless networks. You will always need to try it out and find out the coverage where you can best use for your project and lower your cost of project and maintenance for the future. It's always a consideration. So the best practices is you need to do a survey.
So there was a specific question. It's probably for Diederik. For NRAF tank gauging, it was said that cabling was difficult, but how were the gauges powered?
Now, thank you. Good question. So typically, we get line power for on the top of the tank for these gauges, and usually there's line power available in plants. If that's not available, then you will need to take measures and make external power available through a solar power panel. We have done it a few times, but usually it's not a big problem to get some line power because it's there already for illumination or another means. So that's the question that's the answer to that question. Thank you.
Then there was a question about guidance for reviewing system performance over time to assure that you're not getting a degradation in the signal environment.
In general, the signal strength, the connection conditions of a wireless network is always displayed in your control center. It is part of a network management tool. I see that from all different vendors. So they will tell you some of the conditions in general. You should be able to get those information. However, maybe once a while, you like to, when you have a chance, when you have other applications that you need to go to the field, you can do additional tests. But in general, this is the one basic fundamental requirement for network management for wireless.
The ISA100 wireless devices are all required to collect a lot of network health information, wireless connection health information. So the network managers, the systems might handle that data differently, but the data is all there per the standard. So
there's two questions that probably could be answered in the same answer. The first part is, does ISA100 technology have the same challenges as 802.11, which is typically called Wi-Fi, such as co-channel interference and adjacent channel interference? And then a follow-on is, will ISA100 ever use the 5 gigahertz band?
Maybe let me give a start of the answer, and others please fill in. I think the typical bandwidth requirements for Wi-Fi applications are much larger than ISA100. ISA100, it just needs a very small space to do its communication compared to Wi-Fi. And from personal experience, once we were at a large exhibition with a tremendous amount of Wi-Fi access points that everybody wanted to use for their demonstrations, and a lot of stand holders had problems with getting a connection over Wi-Fi. We at the same time in the same large event hall, we had an ISA100, a few ISA100 transmitters connected to a gateway, and our solution consultant, just out of interest at some point, he just decided to take one of the transmitters and walk the entire event hall, really interfered by hundreds of access points, Wi-Fi access points, and we never had a miscommunication on our ISA100 device, which amazed all the experts, all the Wi-Fi experts that were at the stand. So just to give you a feel for the kind of being lean of an ISA100 connection compared to Wi-Fi. Please, others, feel free to talk to the other point or to the same point.
Certainly, the folks at IEEE who designed the ISA100 radio went out of their way to come up with a radio that wouldn't interfere with Wi-Fi and vice versa. So nothing will interfere with a Wi-Fi radio like another Wi-Fi radio. So to some extent, it's a different problem. That's where listen before talk comes up. A lot of the issues, we didn't want to get into that in this webinar, but a lot of the issue with listen before talk is it can prevent a signal that would have transmitted perfectly and not bothered anybody. Might prevent that signal from ever being sent in the first place, and there's a lot of controversy about that question, and some regulations that some people think are unnecessary. But again, that's that's something to deal with site by site. The system suppliers are well aware of them.
So is that, Jay, are the radios designed so that, similar to Wi-Fi, in that they can use both the 2.4 gigahertz and the 5 gigahertz band?
No, they're only in the 2.4 gigahertz band. We looked at 5 gigahertz when we started, and we thought that 5 gigahertz Wi-Fi might be interesting for very, very critical applications that basically safety interlocks, and you see Wi-Fi being used on assembly lines for 5 gigahertz being used for almost robotic sort of applications. But we never seriously considered going up there. I think there's more interest in the future going down to lower frequencies for better range.
Right, absolutely. So indeed, I can confirm that. So 5 gigahertz will indeed have an impact on the range. It has a higher throughput, which is interesting, for example, for backbone. So we use 5 gigahertz in our long wireless backbone for the larger systems to have up to 300 Mbps throughput. But you will never need that for ISA100 sensor. So there, indeed, 2.4 I think does a better job than 5.
Okay. There's two questions that might be, they're in the same category. One is ISA100 being used for any consumer-type devices? And then another one related to the market is there any work being done with integrating ISA100 into IEC61850?
I can't speak to that. If nobody else can, I think then we have to take the question.
I think the answer is not to our knowledge.
Right. Yeah, I think so. Yeah, when you look at ISA100, it looks a lot like, Zigbee, which is used in BACnet, and that's used in building automation systems, and and also for some of the peripheral consumer style things that are in that same category. So it could be. The 61850, I believe that's the electric transmission and distribution standard, and I haven't heard of any product plans about integrating that into those systems yet, but it could fit in some of that space. I haven't heard of any plans just yet. Okay, so it's 25 after the hour, and a lot of folks have dropped off. So I think we need to just go ahead and bring the webinar and the question and answer to a close. Again, I thank our 4 presenters. There's good information and excellent examples and discussion. And also, I want to thank the participants. I know it takes it's a sacrifice to take an hour or more out of your day to away from work for a webinar like this. So thank you again, and this will conclude the webinar.